Hi everyone, today I'm going to be talking about equivalent fractions and showing you how to use them. So first, let's start off with the definition of a fraction. A fraction is a way of showing a part of something. And we see this in halves or thirds. So if someone says, they've had like half of a bagel, that's like one half of the bagel. It's like half of it. A third of something, like it's split into three parts and you had one of those thirds. Equivalent fractions are different fractions, so not just one, that represent the same part of a whole. And I'm going to draw this out to explain it to you guys. So let's start off with 1/2. 1/2 can be drawn as a circle, and it's split in half, and there's one shaded part of it, right? Because it's like one of the two, and that is one fraction. It's just showing a part of something. And then we've got 3/6. 3/6, it would be another circle. It's just going to be split into 6 parts instead of 2. Oh, I'm going to do it a different way, like this. And 3 out of the 6 parts of the circle are shaded. So these are actually equivalent fractions because they're different, right? It's 1/2 and 3/6. They're not like the same numbers used, but they're the same part of a whole. And they both show 2 circles that are half shaded. So how to get to this connection between these two is using GCF. And GCF is just greatest common factor. And that is the largest factor that all the numbers share. So when you have, when you're using like 2 different fractions. And basically to explain this, you've got 3/6, and you basically, the lowest terms, like when you're writing 3/6 in lowest terms, it would be 1/2. And to get to this, you use greatest common factor, because the greatest common factor of 3 and 6, you just look at the largest factor that both 3 and 6 share. And obviously it can't be 6 because 3 divided by 6 would be 1/2, and that's a decimal within itself, like that's 0.5. So you can't do that. But you can't do 5, you can't do 4, but you can do 3 because 3 divides into both of these and they're still both whole numbers. So when you divide 3 by 3, you get 1. And then when you divide 6 by 3, you get 2. And the rule for equivalent fractions is basically that you divide the same exact number as you do the numerator and the denominator. You can't be different numbers. It's always going to be dividing both by the same thing. So if the greatest common factor of 2 numbers was 5, you divide the top by 5, you divide the bottom by 5 to get the other number, the other fraction. That would be the other part of the equivalent fraction set. So now let's do some problems. Now we're going to write them in lowest terms, which is basically just going from like a fraction with a big denominator to one that has like the smallest denominator possible, but still is an equivalent fraction. So 3/6 to 1/2. You can't really get any smaller than 1/2. So let's do 2/8. Now we have to think of what the greatest common factor of 2 and 8 are. So what I like to do is check if the denominator can be divided by the numerator, and it can in this case. So 8 divided by 2 is 4. And when you have 8 divided by 2 here, you're already getting to your lowest term because you've got the top to equal 1, right? And you can't really go lower than that. So those are that's like a tip I have. Check if the denominator can be divided into the numerator, and then you've got your lowest term. Because in that case, if 8 is divided by 2, the top has to be divided by 2 also, and then you get to 1. But this is another example, 6/15. If we use that rule, it doesn't work because 15 cannot be divided by 6. It can't be 7, 8, 9, right? Because if it's any of those numbers, those are bigger than the numerator, and that will result in a fraction. So greatest common factor that it could be would be the numerator, and in this case would be 2, right? Because it cannot be anything more than 2, or else that would be a fraction on the top, like 2 divided by 4. 8 is divided by 4, but 2 divided by 4 is a fraction within itself, so you couldn't do that. And here, let's start off with numerator 6. 6 wouldn't work, right? Because 15 can't be divided by 6. Then you go to 5. 5 couldn't work because 6 divided by 5 is a fraction. 4 couldn't work. 3 could work though, because you've got 6 divided by 3 equals 2, and 15 divided by 3 equals 5. So it's really just all about using greatest common factor and knowing your greatest common factors. Obviously, they're like, as your numbers get bigger, it gets harder, but finding that factor is what's going to get you to your lowest term. Okay, and now we're going to write the missing number that makes the fractions equal. I taught you guys how to divide to the lowest term, as we did here and in the second page, and now we're kind of going to switch it up and do it the other way around, because not only can you divide, you can multiply to get to higher terms, because you're not always going to be asked to do the lowest term. So here, for example, first thing you want to look at is the denominators of both the fractions. So we know that they're equivalent fractions, and we're just trying to find the missing number. We've got 8 and 64. And if you know your multiplication tables, you know that 8 times 8 equals 64. And as I emphasized earlier, they always have to be divided by the same number, numerator and denominator. The same goes for multiplication. So 8 is turning into 64. 8 times 8 equals 64. Now the top has to do the exact same. It can't be any other number but 8. So 1 times 8 is 8 over 64. So the missing number that makes the fractions equal is 8. Now let's try it with 3 over 9 and something over 3. So this one is actually dividing, right? Because you're going from a big denominator to a smaller one. 9 and 3. So 9 divided by what equals 3? Well, we know multiplication tables once again. It's 3 times 3, so that would be 9. And you're going to divide, and as I said earlier, always divide and multiply by the same thing for the numerator and the denominator. So we're just going to go in and do 3 divided by 3 equals 1. So what's missing is 1. Okay, now for this last example, we've got 10 and 30. So 10 times what equals 30? Well, we know that 10 plus 10 plus 10 equals 30, so it would be 3. And yeah, you're going to write 4/10, then also, once again, multiply it by 3 equals 30. And then 4 times 3 at the top, 4 plus 4 plus 4, it would be 12. So this is obviously not reverting it like to its lowest form. It's making it bigger, actually making the fraction bigger. But they're still equivalent fractions, each and every one of them. 1 over 8, 8 over 64, 3 over 9, 1 over 3, 4 over 10, 12 over 30. These are all equivalent fractions because they represent the same part of a whole. That's it for the lesson on equivalent fractions. Thank you so much for watching.